Imagine a world without smartphones. No laptops, no tablets, even your car wouldn't be able to drive itself. Our world runs on technology, and all of that technology relies on something quite small. These are semiconductor chips. They're the tiny brains behind our digital lives. These chips are everywhere. Today, we're going to lift the curtain on this hidden world. From the mines to the factories, we'll uncover the secrets behind these technological marvels. Semiconductor chips are the unsung heroes of the digital age. They're the tiny engines that power our modern world. But most of us take them for granted. It's a process that spans continents. It involves cutting-edge technology and some of the brightest minds on the planet. The journey of a semiconductor chip begins with something surprisingly simple: sand. Yes, you heard that right. Sand. This sand contains a special element called silicon. Silicon is perfect for creating the tiny switches that form the building blocks of a chip. And it all starts with ordinary sand. But have you ever stopped to wonder why it's called Silicon Valley? Silicon, the key ingredient in these chips, is derived from sand. Companies mine this sand, extracting the silicon and refining it to an astonishing degree of purity. It's a testament to the ingenuity of turning something so ordinary into the extraordinary. The transformation of silicon. The journey from sand to chip is a remarkable feat of engineering. It starts with mining the quartz sand. The real magic happens in specialized processing plants. The raw sand undergoes a series of rigorous purification processes. Impurities are removed step by step until the silicon reaches almost unimaginable levels of purity. It's this incredible purity that allows silicon to perform its magic in electronic devices. The supporting cast beyond silicon. While silicon is the star of the show, it doesn't act alone. These materials, often metals and rare earth elements, possess unique properties essential for the chip's functionality. Take copper, for example. It's an excellent conductor of electricity. Then there's gold, valued for its resistance to corrosion. These exotic materials are used in everything from the memory storage of your phone to the vibrant colors on your laptop screen, from lump to wafer. In its purest form, silicon is a shiny, silvery gray material. It arrives at the fabrication plant in the form of large, cylindrical ingots. These ingots are carefully loaded into specialized machines that resemble giant bread slicers. These machines slice the silicon ingot into incredibly thin discs. These thin discs are the wafers, the foundation upon which our digital world is built. Slicing a silicon ingot into wafers is a delicate operation. The saws used for this task are diamond-edged, ensuring a clean and precise cut. Each wafer needs to be perfectly flat and uniform in thickness. Once sliced, the wafers undergo a rigorous polishing process. This ensures that the surface is free from any imperfections, even at the microscopic level. The significance of wafers. Think of a silicon wafer as a blank canvas for technological innovation. Each wafer can hold hundreds, even thousands of individual chips. The larger the wafer, the more chips it can accommodate, making the manufacturing process more efficient. The evolution of wafer size has been a key driver of technological progress. Now that we have our pristine silicon wafers, it's time to transform them into the intricate chips that power our devices. This transformation involves a complex and multi-layered process known as photolithography. It's a bit like creating a photograph, but instead of light-sensitive paper, we're using light-sensitive chemicals. Ultraviolet light is then shown through a mask, exposing certain areas of the photoresist. The exposed silicon is then etched away, creating the three-dimensional structures that form the transistors and interconnections of the chip. This process is repeated multiple times, layer by layer, building up the complex circuitry of the chip. Designing the chip's brain. Imagine designing a city on the head of a pin. Chip designers create intricate blueprints, packing billions of transistors onto a tiny silicon wafer. Each transistor is like a building in this city, and the connections between them are like roads and highways. Designers use sophisticated software tools to create these blueprints, simulating the behavior of billions of transistors. The architects of the digital age. Chip design giants. Some companies specialize in designing these intricate blueprints. One of the biggest names in the business is ARM, whose designs are found in billions of smartphones. Then there's Qualcomm, known for their Snapdragon chips that power many high-end Android phones. Qualcomm's designs excel in areas like mobile connectivity and graphics processing. And we can't forget about NVIDIA, a company synonymous with high-performance graphics. Handing off the designs. Many chip design giants don't actually manufacture the chips themselves. Once the design is finalized, it's handed off to specialized manufacturing facilities known as fabs. These fabs are where the designs are etched onto silicon wafers. The relationship between chip designers and fabs is a symbiotic one. Inside the clean room, where chips come to life. Step inside a semiconductor fabrication plant, or fab, and you'll enter a world of extreme cleanliness and precision. Workers wear special suits, known as bunny suits, to prevent any contamination. The manufacturing process involves a complex sequence of steps, including photolithography, etching, doping, and metallization. Each step builds upon the previous one, creating the intricate three-dimensional structures that make up a modern chip. The level of precision required is astounding. The science of precision photolithography in action. The magic of chip fabrication truly begins with photolithography. Imagine a series of stencils, each one representing a different layer of the chip's circuitry. Ultraviolet light is projected through these masks onto the wafer, which has been coated with a light-sensitive material called photoresist. The light alters the chemical structure of the photoresist, making exposed areas soluble in a developer solution. The precision of this process is nothing short of astounding. Once the photolithography step is complete, the wafer undergoes a series of additional processing steps. These steps include etching, doping, and metallization, each adding another layer to the complex structure of the chip. Etching is the process of chemically removing material from the wafer to create the desired patterns. After etching, the wafer is implanted with tiny amounts of impurities in a process known as doping. This step modifies the electrical properties of the silicon, enabling it to function as a semiconductor. Finally, metallization involves depositing thin layers of metal to form the interconnections between the chip's transistors. The journey from raw silicon to a fully functioning chip is fraught with potential pitfalls. Each step in the fabrication process needs to be meticulously controlled to ensure quality and reliability. Testing begins with the wafer itself. Each chip, or die, on the wafer is tested for electrical functionality using a probe card. Chips that pass this initial test are then separated from the wafer in a process called dicing. The individual chips are then packaged and undergo further rigorous testing. Only after passing these stringent tests are the chips deemed ready for use in consumer electronics. Remember those tiny squares of silicon, each one a powerhouse of processing ability? They're incredibly delicate. Exposed to the elements, they'd be useless. That's where chip packaging comes in. It's like giving each chip its own custom-designed suit of armor. Then comes the encapsulation process. A mold is placed around the chip and substrate, and a specialized plastic or ceramic material is injected. This material hardens, encasing the chip in a protective shell. Imagine spending months designing and manufacturing a complex piece of machinery, only to have it fail because of a tiny flaw. That's why chip testing is so crucial. It's the quality control checkpoint that ensures only flawless chips make it into your devices. Chip testing happens at multiple stages throughout the manufacturing process. There's wafer testing, where each chip on the wafer is individually tested before being diced. Then there's package testing, where the packaged chips are subjected to various electrical and environmental tests. These tests can involve running the chips at different temperatures, voltages, and frequencies to check for any performance variations. Testing isn't just about finding faulty chips. It's also about ensuring that the good ones meet the required performance specifications. Think of it like an athlete training for the Olympics. Only those who pass the rigorous trials get to compete on the world stage. Ready for the real world. Shipping chips to their final destination. Once the chips pass all tests, they're shipped to companies making our devices. The shipping process is a carefully orchestrated ballet of logistics. Chips move globally via cargo planes, ships, and trucks. Ensuring timely, undamaged delivery is crucial. The global symphony of chip production. The journey of a semiconductor chip from sand to smartphone is a testament to human ingenuity and collaboration. It's a journey that spans continents, involves cutting-edge technology, and relies on the expertise of thousands of people around the world. Think about it. The smartphone in your pocket, the laptop on your desk, the car you drive. They're all made possible by these tiny chips. And behind each chip is a global symphony of scientists, engineers, technicians, and logistics experts, all working together to bring these technological marvels to life. It's a story of innovation, precision, and the relentless pursuit of progress. And it's a story that continues to unfold, with each new generation of chips pushing the boundaries of what's possible. So, as we've journeyed from the sandy beaches to the sterile clean rooms, we've witnessed the intricate dance of technology and human ingenuity that brings a semiconductor chip to life. It's a process that's easy to overlook in our fast-paced world, but one that underpins nearly every aspect of modern existence. These tiny chips, smaller than a fingernail, hold the key to our connected world, enabling everything from instant communication to groundbreaking scientific discoveries. Just as the invention of the printing press revolutionized the spread of information, the semiconductor chip has fundamentally reshaped our world. It has democratized access to knowledge, connected people across continents, and fueled an unprecedented wave of innovation. From the mundane to the extraordinary, the chip's legacy is etched into the fabric of our lives. But the story of the semiconductor chip is far from over. It's a story that's still being written, with each new generation of chips pushing the boundaries of what's possible. As we demand more from our devices, faster processing speeds, longer battery life, more sophisticated capabilities, the pressure on chip makers intensifies. This relentless pursuit of progress drives innovation at every stage of the chip-making process. From the design of more powerful and efficient chip architectures to the development of new materials and manufacturing techniques, the industry is in a constant state of evolution. This insatiable appetite for more powerful chips fuels breakthroughs in artificial intelligence, machine learning, and countless other fields, shaping the future before our very eyes. The journey of a semiconductor chip is also a reminder of our interconnectedness. The intricate global supply chain, spanning continents and involving thousands of companies, highlights the interdependence of our modern world. It underscores the reality that innovation knows no borders, that progress relies on the collaboration of minds and resources from every corner of the globe. This global collaboration has its challenges, of course. Disruptions in one part of the supply chain, whether due to natural disasters, political instability, or unforeseen events like pandemics, can have ripple effects throughout the industry. Yet, it's this very interconnectedness that drives resilience, fostering adaptability and innovation in the face of adversity. The next time you pick up your smartphone, open your laptop, or even start your car, take a moment to appreciate the marvel of the semiconductor chip. Remember the journey it has taken, from grains of sand to the powerful engine driving our digital lives. It's a testament to human ingenuity, a symbol of our interconnected world, and a catalyst for a future brimming with possibilities.